Do you like containers more or serverless more? So a lot of the time these days I hear folks who are adopting one of the other, they really come out with a pitchfork against the other technology. For example, if someone is adopting serverless, they will say, ooh, container is too complex. I don't want all those extra overhead. Similarly, for the folks who are adopting container, they will say, ooh, serverless does not have many features. Container is the best. But like everything else in life, the truth is somewhere in the middle. Container and serverless can work together hand in hand. So in this lecture, I'm going to compare serverless and container on different factors such as how they scale, how they integrate with other AWS services, the cost factors, high availability, etc. Then I'm going to go over designs using both serverless and containers. And throughout the lectures, I'm going to share some handy links for you to study and learn. Before we jump into the actual presentation, a little bit about me for those of you who are new to my channel. My name is Raj. I'm a senior specialist solutions architect for serverless and containers working at AWS. I'm also a published Udemy and Pluralsight author. All right, let's get started. So let's first talk about how does scaling look like for serverless and container. So let's start with Lambda scaling. Lambda scaling is pretty straightforward. Whenever a traffic connection comes, the Lambda gets invoked and then it starts running. As more connections start coming in, other instances of the same Lambda code gets spun up. So one thing to note is each connection invokes a new Lambda instance. One Lambda instance cannot handle more than one traffic connections. For this reason, there is no scaling configuration required because each connection is spinning up a separate Lambda. And you can control the concurrency setting. You can specify how many copies of the same Lambda can run at the same time. One thing to note, previously, each instance of this Lambda function would consume a separate IP address when it is running within a VPC. But after an enhancement, currently the same security group and the subnet combination reuses the same IP address for the Lambda. So you can scale massively using Lambda and don't exhaust the IP address range for your VPCs. Now let's take a look at container scaling. So unlike Lambda, here each pod or each task in case of ECS can handle more than one connection. And as the CPU or memory of this pod reaches a certain threshold, another pod will spun up. So the main difference is in case of container, one container can handle more than one traffic connections. You can configure scaling using horizontal pod autoscaler or HPA, cluster autoscaler or CA for Kubernetes, and for ECS you can reuse the same constructs for AWS for scaling such as application autoscaling, capacity provider, etc. In case of containers, either you are running it in Kubernetes, so pod, or if you are running on Elastic Container Service, in that case, each task will have its own IP address from VPC/subnet. So if your application is scaling up massively, creating a lot of pods or tasks, you have to be mindful of IP address exhaustion. So you can add additional subnet ranges to the cluster even after a cluster is created if you need more IP addresses. All right, now let's take a look at how does serverless and container integrates with other AWS services. So this is one of the superpower of Lambda. Lambda integrates out of the box with over 100 plus AWS services. So let's say you want to trigger a Lambda each time a file is put on a S3 bucket, or you want to process messages from SQS queue or SNS topics. Lambda integrates out of the box with all these services. You don't need to code an integration layer in between. One thing to note, Lambda runs on public or private subnet or outside of customer VPC. No IP address is exposed for the Lambda, even if Lambda is running on a public subnet. And one thing worth mentioning is Lambda has superior integration with API gateway. So we are going to take a look at this design pattern after we go through the comparison. Now looking at the container service integration, pods will integrate with AWS Load Balancer, but you need to install ingress controller or you need to use service. Note that you cannot integrate a Kubernetes pod directly with Amazon API gateway. You need a load balancer in between. ECS can be exposed directly with application load balancer, network load balancer, or API gateway. So due to a recent enhancements, now you can expose your ECS task with API gateway directly using Cloud Map. A typical API gateway pattern that we see with container is API gateway to load balancer to task or pod. Also, unlike Lambda, if your pod or task is running on public subnet, it will have an IP address that you can use to invoke the application directly, even though that is not common in real-world applications. So you might ask, when should I use API gateway and when should I just expose my containers directly with load balancer? That's a great question. So API gateway and load balancer has some similarities and some differences. I have a separate video going over through the factors, so take a look at that if you are interested. Now let's take a look at serverless and container resource configuration. So for Lambda, all you need to define is memory. CPU is allocated proportionally. You can choose memory from 128 megabyte to 10 gigabyte, and the CPU core is allocated proportionally between 1 to 6 cores. Maximum runtime of one Lambda is 15 minutes, and you cannot choose underlying infrastructure. So for example, if your workload is more graphic intensive, you cannot say, hey, run this Lambda on a GPU under the hood. So you cannot individually tweak the CPU and memory in case of Lambda. So if your workload is CPU intensive and you want a high number of CPU cores, but do not want a high amount of memory, that is not possible with Lambda, right? Because in Lambda, all you can choose is memory, and the higher the memory, the higher number of CPU cores you will get allocated. So this is one of the superpower of container. So you can configure CPU and memory allocation. So in case of Kubernetes, in your pod spec file, you can define the resource and limits, configuring how much CPU and memory the pod should use. Or you don't need to assign anything at all, and it will keep consuming more CPU and more memory as needed. However, this is not recommended, because if one of your pod is running some bad process and just keeps consuming more and more CPU and memory, it is going to disrupt the other pods in the same namespace or in the cluster. For Fargate, there is a limitation. So for example, the maximum memory for Fargate is 30 gigabyte and maximum CPU is 4 vCPU. And also for Fargate, you cannot independently control both CPU and memory. There are some selective values you need to choose based on how much CPU and memory you want. So this will get clear when we go over this in a couple of slides. If you are running your containers on EC2 worker node, you can choose any underlying EC2 instance type appropriate to workload. So if your workload is more graphics intensive, you can use those GPU instances, or if your workload is memory intensive, you can utilize more memory intensive EC2s, etc. Now let's take a look at serverless and container high availability. So Lambda out of the box is inherently highly available. So when you deploy your Lambda, under the hood, it gets deployed into multiple availability zones. And the Lambda service works as the load balancer internally. You do not need to have a load balancer. So when you are invoking this Lambda, the Lambda service calls the Lambda function running in one of those availability zones. So each Lambda is deployed on multiple availability zones automatically without additional cost. And since it is deployed in multiple availability zones, there is no disruption even if one availability zone goes down. In case of container, you need to ensure high availability. So in this case, if you are running your container within a pod, you need to deploy and run it in multiple availability zones, and then you need to provision an elastic load balancer to distribute the traffic. So this is very similar to applications running on EC2. If you want to make your application on EC2 highly available, you deploy the same EC2 in multiple availability zone, and then you distribute the traffic using a load balancer. For Kubernetes, pod topology spread can be used to distribute pods in multiple availability zone. And for ECS, task placement strategies can distribute tasks in multiple availability zones. Now let's take a look at serverless and container logging and monitoring. So Lambda integrates out of the box with Amazon CloudWatch, and Amazon CloudWatch will work as both logging and monitoring. For Lambda, if you want your logs to be sent to other logging systems other than CloudWatch, you can use Lambda extensions. So previously, before Lambda extensions was released, all the logs would go to Amazon CloudWatch, and then you can stream the logs from Amazon CloudWatch to other logging systems such as Splunk, Elasticsearch, etc. With the Lambda extensions change, you don't need to send the logs to CloudWatch. The logs will directly go from Lambda to the logging system of your choice. And as I mentioned, Lambda is integrated with CloudWatch for monitoring. There are multiple metrics that's exposed to CloudWatch, and you can define alarms on those for monitoring your Lambda. Now let's take a look at container application logging. Since Kubernetes is open source, you need to install FluentD or FluentBit in the cluster to send the logs to CloudWatch, S3, Elasticsearch, etc. For ECS, various log drivers are supported to send the logs. So the difference between EKS and ECS on this factor is, on EKS, the application team needs to install the FluentD FluentBit agent. But with ECS, you simply check a box saying, I want to send all the logs to AWS Logs or Splunk, and AWS will install the appropriate agent for you. You don't need to have the additional overhead of installing the logging agent yourselves, like you do with the Kubernetes. Now let's take a look at container monitoring. So similar to logging, for Kubernetes, you need to install an agent to work with Prometheus, Grafana, or CloudWatch Container Insights. For ECS, ECS will integrate out of the box with CloudWatch, where you can monitor your tasks using different CloudWatch metrics. So now let's talk about security. So this is a big area. Container and serverless security is a separate lecture on its own, but some things to keep in mind when you are designing your applications. So Lambda, along with other serverless services, all have FedRAMP high compliance. So if your workload required high level of compliance, serverless is good for that. And beyond that, for the application security, you can control what service or what API can invoke Lambda using Lambda resource policies. And you can control what services can your Lambda invoke using IAM role for the Lambda. And for API gateway, one popular topic is authentication and authorization. So there are multiple authentication authorization methods with API gateway, starting with API key, IAM keys, Cognito, Lambda authorizer, etc. So I have a separate video on that. I'll keep a link up top so you can check it out if interested. And check out the Lambda Security Best Practices Guide. I have given the link at the bottom of the slide. Now let's take a look at container security. So container security is a super broad area. But a couple of things to keep in mind. EKS on EC2 and ECS on EC2/Fargate are FedRAMP High and available in Gulf Cloud regions. The pods and tasks support security groups and IAM roles to access other AWS resources, so you can reuse your knowledge of IAM. But on top of that, especially for Kubernetes, there are multiple mechanisms for security. So you need to learn RBAC or role-based access control, IRSA, network policies, OPA, etc. So check out my container playlist to go deeper in these different security areas. And one link that I personally use a lot in my day-to-day work is EKS and ECS Security Best Practices Guide, and these are the links. All right, let's talk about serverless and container cost. So I don't want to go through the calculating cost for all these services because I have already done that in other videos. But a couple of things to keep in mind when you are thinking about cost. For ECS, AWS can manage Spot for you. So Spot instances or Spot Fargate are 70% cheaper than their non-Spot counterpart. ECS Fargate can also run on Spot out of the box. So you can say that 30% of your task for Fargate can run on Spot, 70% on regular infrastructure. So AWS can manage that for you. For EKS, EC2 worker nodes, customers can use Spot, but EKS Fargate does not support Spot yet. And utilize CloudWatch insights to optimize both Lambda, ECS, and EKS. And there are a lot of third-party tools as well. A couple of the very popular tools for cost optimization for container is KubeCost, Cloud Health, etc. For Lambda, there is a calculator where you can put estimate amount of traffic and the memory and duration for your Lambda, and it will give you the monthly cost. But I wanted to go over a case and calculate cost for ECS EC2 mode versus ECS Fargate mode, and this is also true for EKS EC2 worker node versus EKS Fargate mode, because there could be some confusion here. So for ECS EC2 mode, you pay for the EC2 worker node charges, so pretty flat amount. For the ECS Fargate, the charge is based on CPU, memory for the Fargate, and duration. So remember I said you cannot really choose any amount of CPU and memory even with Fargate. So this is the mapping table. So for example, if you choose 1 vCPU for the Fargate, you need to choose the memory values between 2 and 8 within these values. And then per vCPU per hour and per gigabyte memory per hour is charged accordingly. So if we take a look at an actual use case, let's say you are running a EC2 worker, and that EC2 worker is M5 large, which has 2 vCPU and 8 gigabyte, and it's running for 720 hours or 30 days. And each task consumes 1 vCPU and 4 gigabyte of RAM. So the first task keeps running because it needs to serve any incoming API connections. And the second task runs for 10 hours. So the second task only comes up when the application is scaled up. So we are assuming the application runs on a scaled up state for 10 hours. So the cost is flat. It's basically the hourly charge of the EC2 multiplied by 720 hours comes to $69 per month. But keep in mind, you also need to spend cost to manage the EC2. So with EC2, you need to control the AMI and the DevOps toolchain to rehydrate the AMI, etc. The EC2 Fargate mode, so this is the part of the confusion. Note that one Fargate task will run continuously. It does not only run when the API gets invoked. it needs to keep running so that it can serve any incoming API connection. So the Fargate Task 1 cost will be for whole 720 hours, comes down to $42 per month. The Fargate Task 2 is where you will save money on Fargate, because this Fargate Task 2 will only run for 10 hours, costing you only 21 cents per month. So again, based on your use case and traffic, the cost will be different. So always do your own cost calculation before coming to the decision which option will be cheaper. So now let's take a look at serverless and container design patterns. So a recent development is, even with Lambda, you can use containers. So you can create your container image, and let's say you upload that image into Amazon ECR. You can also use Docker Hub, and then you can create your Lambda using that container image. In this way, you can utilize your existing container knowledge, existing container toolset for development, unit testing, etc. One thing to note, container does need to be changed a little bit to use with Lambda. So I have a separate video on this going deep along with demo. Please take a look if interested. Now let's look at API gateway integration with EKS. So as we mentioned before, Kubernetes can only be exposed through application load balancer or network load balancer. You cannot integrate API gateway directly. And this application load balancer and network load balancer will work with ingress controller, and they will work as ingress. For ECS as well, you can use API gateway to load balancer to ECS, but with a recent development, you can reach to ECS directly using AWS Cloud Map, and I have given the link to the blog. Serverless really shines in one area, which is event-driven patterns. So by event-driven pattern, couple examples could be, if you are putting an object on S3 bucket and you want to process it using some compute layer, Lambda integrates directly. If you want to do the same thing with, let's say, Kubernetes or ECS, this S3 bucket needs to call a Lambda, and maybe that Lambda invoke a EKS or ECS using a load balancer. So it becomes a little clunky. Same thing for SNS topic, can integrate with Lambda directly, and SQS as well. Lambda can poll the SQS queue and process those messages. If you want to use, let's say, EKS or ECS with SQS, you need to poll it. You need to design and deploy the polling part using your application code as well as the processing part. So this is a little bit deeper subject. So if you want to learn a little bit more on the how SNS, SQS, and Lambda works with each other, as well as when to use Event Bridge versus SQS versus SNS, check out my other videos. I will give the links in the description. So what's in the roadmap? So container roadmap is open. So this is the link on the bottom of the slide, and each feature is tagged appropriately, such as EKS, ECS, etc. So you can filter it and check out the feature roadmap for which you are interested. So couple of other handy links that I wanted to share. So for serverless, this website, serverlessland.com, is an excellent resource for a collection of all serverless official blogs, workshops, etc. Even though the name says serverlessland.com, this is actually created and maintained by AWS folks. For EKS and ECS, we have eksworkshop.com and ecsworkshop.com. But if you are someone who are just starting with containers, I highly recommend starting with this containers-immersionday.workshop.aws. This workshop starts with the basics of Docker, Dockerizes a simple application, and shows you how to deploy it in ECS or EKS. After you are done with this one, you can move on to those eksworkshop.com and ecsworkshop.com. Alright guys and girls, that's the end of the lecture. Let me know in the comment section if you guys and girls liked this kind of little bit longer, deeper dive lectures. I can make more of this if needed. Alright guys and girls, that's the video. If you like this video, if you found this video helpful, learned something new, please do all the YouTube stuff. Smash that like button, subscribe, comment, share. This is still a relatively small channel, so help us grow the channel so that we can do more awesome things. Alright guys and girls, that's it for this video. I'll see you in the next video. Bye.